Okay, here we go. Comment below if you know a way for me to share my face. That'd be cool because I'm using Windows 10 and I'm using the Xbox screen recording software to do this. And I'm a PlayStation person. I don't like Xbox, but it's helping my students. Look at the sacrifice I'm making for you guys. Anyway, let's get into this. We have 26 raised to the 9x plus 5 equals to 1. We need to get both of these bases the same. So right now it's at a 26. This one's at a 1. They are not equal to each other. How could I make a 1 be a 26? Because if I have the same base, I can use our log tricks. So I'm going to keep this guy the same. 26. I don't know why I'm writing my 9 like that. 9x plus 5. And then we say, instead of 1, I want something that's equal to 1 but has a base of 26. So I'm going to go 26, and I'm raising that to the 0. Anything raised to the 0 power has to be 1. Well, if I know that both of these bases are now the same, what am I going to do is I'm going to apply a log, because what is the inverse of exponential? That's right, it's log. Yes, there you go. Bing, bing, bing. What I do to one side, I do to the other. So 26. I need to get like a pin. Alright, so the logs are going to cancel out with the log and the what we're evaluating that base at. So log and the 26 will cancel out with each other. And I'm looking at, nope, not looking at a 2 anymore. I'm looking at our 9x plus 5 has to now be equal to the 0. Alright, well now this looks like algebra that's a lot more manageable. So let me go, because I want to solve for x, right? I want to move the 5 over here, and then I want to divide by the coefficient. I'm leaving it right there because I expect you guys to know how to do the algebra part, because we're in Algebra 2. Alright, this is the stuff that you might have forgotten based off of our coronavirus missing of school. Alright, so continue the work from there. Be quiet. Alrighty, so this is question 2. I don't know why it doesn't come up over here. We've got some lag going on or something. Anywho, we need to solve for the x's, which are in the exponent. My daughter's making fun of me, so that's fun. We have a base of 3 and we have a base of 9, and we need these bases to be the same to apply our log trick. What I like about 9 is that I can turn it back into a 3. So I'm keeping this one the same, 3x minus 2, and instead of 9, I'm going to go ahead and write a 3. Well, I need to ask myself, what needs to go here? What needs to go in the exponent? 3 to the what makes 9? That's going to be 2. Put a 2 out in front. And because I am splitting basically 9 up into an exponent, into its exponential form, I'm multiplying by what was left in the exponent, or how should I say that better? What was originally there. That's a better way to say it. So from that first video, we apply log and the 3's cancel. So instead of me taking the time to try to squiggle in log with this janky mouse that I'm using, I'm just going to go ahead and cancel out the 3's because we're applying that log trick. If you need further like video evidence of that, you can Google log properties, or you can look at the question 1 video, and just know that when you have the same base, you get 3x. You can cancel out those bases and go 3x minus 2. And instead of writing 2 times the quantity of 4x minus 1, I'm just going to go ahead and distribute and go 8x minus 2. And I'm going to leave it right there for the rest of you to do. I'm going to give you a hint, of course. We're going to take the 3x, move it over here, take the negative 2, move it over there, and if you did this correctly, your answer is neither positive nor negative. That's a bad hint because you should know the answer by now.
Yay! So in this one we can say bye.
Yeah. Alright. So the kids are going to make a cameo at the end on this one. But this is going to be the last video because question 4 is exactly like question 1, just different numbers. So you're going to apply the same methods. Okay, so now we have a 3 over here, and we have a 1 and 27, 1 over 27 over here. Again, I have to get these bases the same to use the log trick, okay? Math is giving me clues all the time. What do I like about 3? What do I like about 27? If I'm thinking exponentially, I know that 3 times 3 is 9, and another times 3 is 27, and because it's a fraction, that must mean we have a negative exponent. So we're going to go 3. You ever notice on Khan that they always manipulate the right-hand side? I don't know that to be certain because this is like, I don't know, one of my first, not my first, but it's like I haven't done a lot of these, but I'm noticing that it's always I have to manipulate the right side. So we're going to go 3, and I'm going to change it up. Look at this color, folks. We're going to go 3. I'm denoting change in color. 3 to the negative third is going to give me 1 over 27. What remained the same was this negative 8. And remember, we are multiplying. All right, boom. So now, I'm going to go ahead and go 3, 7 minus 2x. And I'm going to do the multiplication. So I have 3. And the only thing I've changed here was the positive 24. Using the log trick, these guys are going to cancel out. And now I'm left with 7 minus 2x is equal to, you guys tell me, okay? I'm doing less and less of this stuff so you can do it yourself. Kids, anything you want to say?
Bye. Time to charge up.
That's Anthony charging up. We like Dragon Ball, so there that is.
And we're playing Dragon Ball.
Oh, we're playing Legos. Alright. Do the rest of the math yourself. Stop being lazy.
Back on video now.
Alright, hold on. So, I forgot to mention that once you get this here, we're obviously going to solve for x, so remove things from the last step, divide by the coefficient. But I think Khan has you can sneeze, it's fine. I believe Khan won't allow you to put it as an improper fraction for some reason, so you may need to get a calculator and can you hold that for a second? Khan may need you to get a calculator, divide it, and enter in the decimal instead of the improper. I don't know why they do that. Anyway, Just thought I'd add that. Alright. Peace. Good luck.